Alright, welcome everyone. So last video we were going over constitutional isomers and I gave you some of those IUPAC names. So now we're going to go over the rules for alkanes and cycloalkanes, and then next video we'll go over some more practice problems to kind of solidify this. So just kind of wanted to type these definitions up, kind of get you started. So just go over it. Like alkanes are all single bonded molecules comprised of carbon and hydrogen atoms. A saturated hydrogen carbon is in the form of C to the N, H to the 2N plus 2. Might have went over that in a previous video. So for example, we have C, so C1, so 1 carbon, so there would be 4 hydrogen in a saturated. That's methane. And if we jump to like C3H8, sorry, then you'd have propane. We'd have our 3 carbons, all with our hydrogen. There you go. 1, 2, 3, 4, 5, 6, 7, 8. Excuse me. So this IUPAC naming system includes a parent chain, its substituents, and the location of them. So mainly you will probably need 1 through 10. Shouldn't really jump up too much, but it's good to know just in case you have them. So the number of carbons will determine the parent chain name. So if we have 1, it's meth, 2 is eth, 3 is prop, 4 is bute, 5 is pent, and then this is kind of like the sides in geometry class. You got hex, hept, oct, non, and dec. So for example, if we had 1 carbon, we would have methane. If we had 5 carbons, 1, 2, 3, 4, 5, that would be pentane. But we know that molecules get a little more trickier. So now we're going to start adding substituents. So if we had 5 carbons, 1, 2, 3, 4, 5, and if we had just a group right here, 1 carbon's out of that chain, that would be a methyl group. So we'll just kind of practice going over identifying the parent chain. Identify, don't know how to spell, so identify the parent chain. Alright, so if I gave you something that looks like this, 1, 2, 3, 4, I had 1, 2, 3, 4, 5. You just need to find the longest chain. So maybe we're starting from the left. We got 1, 2, 3, 4. If I went down, I'd have 5 and 6. But if I went up, I'd have 5, 6, 7, 8, 9. So there's our parent chain. Just keep doing different colors. Hopefully it doesn't bother anyone. So that parent would be non. The parent would be nonane. And we can just go over our substituent here. Would be, if we have 2, 1, 2, would be an ethyl. If we keep it going, 1, 2, 3, 4, bring this down, 1, 2, 3, 1, 2, 3, 4, 5. Alright, we'll number it again and say 1, 2, 3, 4. If I kept going, I'd have 5, 6, but we can make it longer. 5, 6, 7, 8, 9, 10. If I went the other way, it'd be 5, 6, 7, 8. So this is the longest. This is the parent chain. And that's 10, so we have decane as the parent. Some of the substituents. To number those. 1, 2, 1, 2, 3. So our substituents for 2 would be an ethyl and a propyl. So kind of look at the chart if you haven't written it down. Ethyl and propyl, 2 and 3. So now we're going to draw this out twice. 1, 2, 3, 4, 5. Bring it down. 1, 2, 3, down. 1, 2, 3. So we have this option. I'm going to just redraw this. Come on. Okay. We can look at this two ways. So we had 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So both are 7. Now we have to see which parent chain is correct. So let's count the number of substituents that we have. This would be 1, this would be 2, 3. Yes, 1, 2, 3 versus 1, 2, 3, 4. So this is the correct one. The more substituents you can get. So if there is a tie, for parent chain, pick the one with more substituents. So if we're naming ring compounds, this is moving on to something else. If we're naming ring compounds, add cyclo. So we had 3 carbon, we'd have a cyclopropane. If we had 4 carbon, we'd have cyclobutane. I'll try to draw this. If I had, oh, let's see if they have one of these. Don't even know how to insert a shape right now. Oh, maybe we can use those later, but great. Let's draw it out. 1, 2, 3, 4, 5. This should be, we have 5, so cyclopentane. Alright, let's keep it going. So we'll do like 1 or 2 more practice, and then we're going to move on to some special substituents. So let's get a ring one in here. So if we had 1, 2, 3, 4, 5, 6. And then we had a methyl group attached. So to name these, or to number them, we'd want to start with having the lowest number assigned to a group, or a lowest number assigned to a substituent. So for example, we'd want this to be 1, and we can go around either way because everything else is the same. 2, 3, 4, 5, 6. We know our parent is a cyclohexane. We know our substituent happens at 1, and it's a methyl. So the total name for this would be 1-methyl cyclohexane. Moving on, if we had something like this, 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3, 1, 2. So there's two ways we can name this, either from the left or to the right, but I guess we need to find our parent chain first. So we'd say 1, 2, 3, 4, 5, 6, 7, 8, 9. For here, this 2 would be less if we went the other way. It would be 1, 2, 3, 4. So we know that makes sense. So we know that's the right way to do it. So just kind of highlighting our methyl groups, or our substituent groups. We don't have any methyl groups here. Our parent is 9, so it's nonane. We have a 2, 1, 2, 3, a 2-meth-eth propyl group. And we have a 6-ethyl group. So, to name it, 2-propyl, 6-ethyl nonane. So then let's go into complex branches, complex substituent branches. So the base would, if we had a parent group, we moved it to 1, 2, 3. You know, we'd have 1, 2, 3 carbons here. This would be a propyl group. Okay, but then we could have our parent and have it equally distributed. Had 1, 2. So we know there's 3. So we know there's 3 carbons here. We could name it 1-methyl ethyl group, or if you can identify this as an isopropyl. So that's 1. If we have our parent again, if we had 4 now, we had 1, 2, 3, 4. It's butyl. Then we show 1, 2, 3. We have 4 again. It would either be a 1-methyl again, now propyl. Kind of see that relationship here. But it's also a sec-butyl. Now we got 1 or 2 more we can show here. Got our parent. We got 1, 2, 3. Instead of being at the 2, instead of being at the 1, it's now at the 2. That would be 2-methyl propyl, which is the same as isobutyl. Got our parent. That would be a tert butyl. You could just name it 1, 2. So at the 1 substituent, you have 2 methyls, which would be 1,1-dimethyl ethyl. Alright, so after these complex branches, I just want to go over all the rules and just kind of had it typed out. So some of the IUPAC rules for all these substituents. If one substituent is present, the substituent should be numbered at the lowest possible carbon. If there's multiple, number the parent chain to give the first substituent the lowest number. If there's a tie, and if there's a tie for that, then the tiebreaker would be by the second substituent location would want to be lower than the other second substituent location. If locations are all the same, the tiebreaker is decided alphabetically. Also, put the number and name of each substituent before the parent chain in alphabetical order. Prefixes are ignored. So, when we go over these problems in the next video, we're going to want to identify the parent chain, identify substituents and name them, number the parent chain, giving the lowest number to the first substituent. The first substituent should have the lowest number, and then we'll list alphabetically. Alright, and that's it. Thanks for listening. Thanks for watching. Hope you learned something.